Let me welcome you to this lecture. We have been discussing about the chemistry of hydrides of boron, and we have so far discussed about a very ingenious way developed by William Lipscomb for calculating the number of different types of bonds present in a given boron molecule by just looking at the formula of the boron molecule. So he developed a code known as the Styx code, and one can calculate the Styx code, or which essentially are the number of different types of bonds within a given boron molecule. And from the Styx code, one can try to find out or deduce the structure of a boron molecule. So let us now work out a couple of examples of calculating Styx codes for different boron molecules, and then also try to figure out the structure of these boranes by looking at the Styx code. So let us begin with B3H9. Already in one of the earlier lecture we have calculated the Styx code for B2H6, and from there we could also deduce the structure of B2H6, or we could verify the structure of B26H6 with the Styx code that we have obtained. So in case of B3H9, as we do not know the structure of B3H9, and from the Styx code we will try to predict the structure of B3H9. So let us begin. So we know that when trying to find out the Styx code of a boron molecule, the first step is to write the formula of the boron molecule in BHP HQ format. That is, we have to write the formula of the boron in this particular format. So when we try to write the formula of B3H9 in this format, what we can do is that in the step 1 we can write, because there are 3 boron atoms, so we can write BH3. We can assign one terminal hydrogen atom to each of the 3 boron atoms, and then we can write BH3, and we are then left with 6 additional hydrogen atoms. Now from the calculation of Styx code, we can find out the value of S. We have already learned how we can predict the value of S, because the value of S has to be either less than q by 2 or more than q by 2, or equal to q by 2, or it has to be either lower, either equal to or less than q. So from here we can also write that P for this B3H9 is equal to 3, and Q, value of Q is equal to 6. Now from here we can write the value of, or we can predict the values of S, because we know that S has to be either greater than equal to or equal to Q by 2 and smaller than or equal to Q. So what we can write is that that is Q is equal to 6. So S has to be greater than or equal to 3 and smaller than or equal to 6 from the calculation of Styx number. We have already found out this particular relation, or we have deduced this particular relation already. So from here we can tell that three different values of S are possible for this particular boron molecule. So let us list these S values in the form of this table here. So we can have S equal to 3, 4, 5 or 6. From this condition we can write different values of S. Now from the relations, other relations, we can predict the values of Ty as well as X. So we know that P is equal to S plus T. So from here we can write T is equal to P minus S, and we already know the value of P over here is equal to 3. So T must be equal to 3 minus S. So for different values of S we can write the values of T. So when S is equal to 3, 3 minus 3 will be equal to 0. So T is going to be equal to 0. When S is equal to 4, 3 minus S is going to be equal to minus 1. And when S is equal to 5, T is going to be minus 2. And when S is equal to 6, T is going to be equal to minus 3. So again, we can write, or we know that Q is equal to S plus X. And from here, we can write that X is equal to Q minus S. So which is Q is equal to 6 minus S. So for different values of S, you can write the values of X over here. That is, we can get it by deducting the value of S from 6, which is equal to Q. So this is going to be when S is equal to 3, X is going to be equal to 3 as well. S is equal to 4, X is going to be equal to 2. And when S is equal to 5, X is going to be equal to 1. And when S is equal to 6, X is going to be equal to 0. So these are the values of X that we can get. And the values of Y we know we can find out from this S minus X divided by 2 from this particular expression. And here we can substitute different values of X and S to get the values of Y. So for this particular, when S is equal to 3 and X is equal to 3, S minus X is going to be equal to 0 and Y is going to be equal to 0. This 4 minus 2 divided by 2 is going to be equal to 1. 5 minus 1 divided by 2 is going to be equal to 2. 6 minus 0 divided by 2 is going to be equal to 3. So these are the values of Y, S, T, Y and X that we have obtained for B3H9. And from here, what we can tell is that for B3H9, only one Styx code, or we can rule out these 3 Styx code where there are negative numbers, because these numbers are improbable for Styx code, and that is why the Styx code of B3H9 is 3003. So from here we can predict the structure of B3H9 as well, because in B3H9 there must be 3 from the Styx code of B3H9 we can say that there are 3 BH bonds in B3H9, and then there are no BB bonds, as well as the number of BB 2 electron bonds are also equal to 0, while the number of BH2 groups is equal to 3. So from here we can write the structure of B3H9. So we have now drawn 3 BHB bonds here, and since there are no BBB 3 center 2 electron bond and no BB 2 center 2 electron bonds, and there are 3 BH2 groups, so to all of these boron atoms, 2 terminal hydrogens are attached, and this is the structure of B3H9 that we get from the Styx code that we have calculated out from the formula of this boron molecule. So here we could rule out all the other Styx codes because we have negative numbers, and negative numbers are improbable in case of a Styx code, and we could rule out these Styx codes, and we could easily predict the correct Styx code, and also from there we can predict the structure of B3H9. So let us proceed further and then try to deduce Styx code for higher boranes as well, where we will have to draw the structures or probable structures when looking at the Styx codes, and then rule out some of these structures by using the empirical laws, and then obtain or predict the correct structure of the boron molecule. So the next borane molecule from which we will deduce the Styx score is B4H10. We have already drawn the structure of B4H10 and we know the structure of B4H10, but here we will see how if we can predict the same structure by using Styx code or not. So again, when we write the formula of B4H10 in the required format for obtaining the Styx score. So we can write it in this way, and from here we can tell the value of P here is equal to 4, while the value of Q here is equal to 6. And again, what we can write is that the value of S has to be greater than or equal to 3 or smaller than or equal to 6. And again, let us list different values of S and then find out the values of T, corresponding values of T, Y and X from these values of S. So the values of S, which are probable, again are 3, 4, 5 and 6. And the values of T, again what we can write is from the expression that P is equal to S plus T, that T is equal to P minus S. From here what we can write is, since P is equal to 4 here, so 4 minus S of different values of S will give us the corresponding values of T. So when S is equal to 3, T is going to be equal to 1. 4 minus S is equal to 1, and then when S is equal to 4, T is going to be equal to 0. When S is equal to 5, this is going to be minus 1, and when S is equal to 6, this is going to be equal to minus 2. Again, the values of X we get by deducting the value of corresponding value of S from the value of Q. So since Q is equal to 6 here, so again we can write corresponding values of X from the values of S here. So 6 minus S, when S is equal to 3, X is also going to be equal to 3. When S is equal to 4, this is going to be equal to 2. When S is equal to 5, this is going to be 1, and when S is equal to 6, X is going to be equal to 0. And again, value of Y we obtain by from this formula. So S minus X divided by 2, 3 minus 3 divided by 2 is going to be equal to 0 here. 4 minus 2 divided by 2 is going to be equal to 1, and 5 minus 1 divided by 2 is going to be equal to 2, and 6 minus 0 divided by 2 is going to be equal to 3. So we have all possible Styx scores for B4H10, and again we could rule out these two sets of Styx code because there are negative numbers involved in these two Styx code, but we have now two sets of Styx codes which are valid from the first empirical law, which tells that negative numbers or Styx codes with negative numbers are improbable. But these two sets of Styx codes does not have any negative number. And now what we will have to do is, we will have to draw the structures, corresponding structures for these two Styx codes, and then use the other empirical laws, or try to use the other empirical laws and then find out which particular Styx code is going to be correct by looking at the structures. So let us try to draw the borane with this particular, or structure of the borane with this Styx code, that is 3103. So we have, in this borane we have 3 BHB 3 center 2 electron bonds, then we have 1 BBB 3 center 2 electron bond, we have no 2 center 2 electron BB bonds here, and there are 3 BH2 groups in this borane molecule. So based on that, we can draw the structure probable structure of B4H10 by putting these many different types of bonds here. So 3 BHB bonds. Let's draw 3 BHB bonds between these 4 boron centers here. Then we have one BBB bond. So let us draw one BBB bond. And this is how we draw the 3-centered 2-electron BBB bonds in this particular fashion. That is, the bonds are drawn in 3-centered 2-electron BBB bonds are drawn in this way, and that is how we see how we can connect the 3 boron centers by using one 3-centered 2-electron bond in this particular fashion. So that is how we draw the 3-centered 2-electron BBB B bonds, and now we have no BB 2-centered 2-electron bonds here, and there are 3 BH2 groups in this boron molecule. So let us place 3 BH2 groups in this boron molecule, and then the last boron center, have only one terminal hydrogen atom here. So that is the structure of the boron with the Styx code 3103. Now let us also try to draw the other structure for the other Styx code, that is 4012. So let us draw 4012 here. So when we have 4012, there are 4 BHB 3-centered 2-electron bonds, no BBB 3-centered 2-electron bonds, then one 2-centered 2-electron BB linkage, and 2 BH2 groups. So let us try to draw a structure for having these many different types of linkages here. And again, let us so 4 BHB linkages. So let's connect all the 4 boron centers with one BHB 3-centered 2-electron linkage here. Then no BBB 3-centered 2-electron linkage, but one BB linkage. So let's connect 2 of the boron centers by using one 2-centered 2-electron boron-boron linkage here, and then 2 BH2 groups. So let's place the BH2 groups in this way, and these boron centers will have only one hydrogen terminal hydrogen atom attached to them. So that is the structure that we can get for this Styx code, that is 4012. Now one of these Styx code or one of these structure is correct for B4H10, and which particular structure is going to be correct, that we can find out by using one of the empirical laws or rules for deducing the Styx code. And the second law rule, empirical rule, says that these boron molecules have or most of these boron molecules have two-fold symmetry. That is, they must have a C2 axis of symmetry, and if you look at which of these structures have a two-fold axis of symmetry, or you will realize that for this particular structure we can bisect this structure by two equal halves, as well as we have there are several C2 axes of symmetry in this particular structure, while in this case the structure is less symmetric and it does not have two-fold symmetry in this particular structure. So this structure of B4H10 should be correct as per the empirical law, and that is the case. We have seen experimentally, or we have also drawn the structure of B4H10 earlier when we have drawn the structures of all these closure Neto and arachnoboranes, and we found out that this is the structure predicted for B4H10, again from that methodology as well, and again from Styx code as well. We can say that this is the structure of B4H10, and the correct Styx code for B4H10 is 4012, and we can rule out this particular Styx code by looking at the structure and then using one of these empirical laws. So let us proceed further and then try to draw or try to deduce the Styx code for another boron molecule. And the borane molecule that we will take now is B5H9. Again, the first step to determine the value of P and the value of Q. So P is equal to 5 and Q is equal to 4 in this case. So we can again find out the value of, or the probable values of S from here. So S must be greater than or equal to 2 and smaller than or equal to 4. From this, from the value of Q we can write that, and then we can write different values of S and then try to deduce the corresponding values of T, Y and X. So the values of S which are possible are 2, 3 and 4. These three values of S are possible from this relation, we can say. And again, the value of T we can write from the expression T is equal to P minus S and P is equal to 5. So 5 minus S, so T is equal to 3 here, and this is going to be equal to 2, and this is going to be equal to 1 here. And then the value of X, again we can write Q minus X is equal to X and Q is equal to 4. So 4 minus X is equal to 2, this is 1 and this is 0. Then we have the value of Y again, S minus X by 2. So 2 minus 2 by 2, this is equal to 0. 3 minus 1 divided by 2 is equal to 1. 4 minus 0 divided by 2 is equal to 2. So we have three different sets of Styx number for this borane molecule, that is B5H9, and in this case none of these Styx code negative numbers are present, and that is why we will have to draw the structures, corresponding structure for each of these Styx code, and then see or then try to find out the correct structure, correct Styx code by using the empirical rules. So let's try to first draw the structure with the first Styx code here, 2302. So 2 BH B linkage, 3 BB B linkage, 0 BB linkage, 2 BH2 groups. So the corresponding structure we can draw over here is going to be, let us draw it here, 2 BH3 bonds. So let us first draw 5 boron centers maybe. And we will have to draw 2 BHB linkage between these boron centers, and we will try to be symmetric, or we will try to draw the bonds in a more symmetric way. So 2 BHB linkages we have drawn. Now we have to draw 3 BBB linkages. So again, let us try to be symmetric here. And 0 BB linkages and 2 BH2 groups. So we can draw the BH2 groups here. H, 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 H here. Then let us proceed further and then draw. So this is the structure that we get for this Styx code 2302. And then let us also try to draw structure for 3211. This Styx code 3 BH B linkage, 2 B linkage, and then 1 BB linkage and 1 BH2 group. So let us try to draw this structure as well, 3, 2, 1, 1, and this Styx code. So once again, let's place 5 boron centers here and 3 BHP linkages. So 3 BHP linkages we have written and 2 BBB linkages. This is how we could place 2 BBB linkages, and then we also have to draw 1 BB linkage, one BB linkage between these two borons. We can place one BB linkage and one BH2. So let's place the BH2 group over here. So let's also, here we have the terminal, we'll have to draw the terminal boron hydrogen atoms. To each of these boron centers, we must place one terminal hydrogen atom. So now we have this structure corresponding to this particular Styx code, that is 3, 2, 1, 1, and what we have. Let us now try to draw the other structure or last structure for the last Styx code, that is 4, 1, 2, 0. So we have 4 BHB linkage, 1 BBB linkage, 2 BB bonds, and 0 BH2 groups. So let us try to draw this particular structure as well. So 4 BHB bonds. So let us place BHB linkage in this way, 4 BHB linkage, 1 BBB linkage. So let us place 1 BBB linkage here in this fashion and 2 BB linkage. So let's place also 2 BB linkage in this way and 0 BH2 groups. So no BH2 groups are present and 1 terminal hydrogen must be attached to each of these boron centers in this fashion. Now, when we try to find out which particular structure among these are correct, or by using the empirical laws, what we can see is that this in this particular boron center here, this is surrounded by 4 boron centers, and this boron center, the central boron center over here, is going to participate on only one 3 center 2 electron linkage, and that is, in this case we have seen that it is participating in 3 3 center 2 electron linkage, while in this case again it is participating in 2 3 center 2 electron linkages, and only in this particular case it is the central boron atom here, which is surrounded by 4 boron centers, is participating in only one 3 center 2 electron linkage, and that is why this particular structure is going to be more probable or is predicted by using the empirical laws, and this is the correct structure for V5H9 that we can say from the Styx code by using the empirical laws. So what we have seen here is that by using the empirical laws for predicting the structure of Styx code, we can predict the structure of different boron molecules to do with good accuracy, and one should practice, or one should practice with this calculation of Styx number, and then try to draw the structure of different boron molecules, other boron molecules as well, so that you can learn, or you can be able to predict the structure as well as the Styx code of different boron molecules. So with this, let me conclude this lecture, and I thank you very much for being with me during this lecture.